What up, guys? I'm gonna make sure the audio is good tonight. So I'm gonna try. Okay. I should be hearing both of those right now, and I'm not, so this is working out really well already. You weren't expecting to get an Xbox One controller, I imagine. Okay, let's see the mixer. Okay, so there we go, maybe. It's probably best just to do this. Why did it disconnect? You son of a bitch. Oh, this fights it. I remember that. That's why I have to take it off here. I've had this problem in the past, and I am replicating it right now. Like a dummy. Close all this shit. Close. 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 Okay, so I want to be able to show you guys the kind of schematics I'm looking over. So my computer is shitting its pants right now. We always treat the yellow screwdriver well, Grass Puddle. So we gotta forget this. Remove device, because it fucking tries to connect all the time. There we go. Okay, now I can have these on my phone. And if I turn this all the way up. All right, how's my volume sound? Not so bad. I'm gonna make myself full on, no lower volume. That way, if you want to turn me down, you can. Hey, what's up? What's up, crazy? What's up? What's up? What's up? Okay. Okay. If the volume changes at all, yell at me. I need to, okay, anyways, here we are. All right. The Centipede circuit board, right? Okay, so every day I'm looking at this, I learn a little bit more. And we will, as fast as I physically can, get to the point where we can diagnose these. There is a tool I want to get that will help me find errors. It was called an Atari Cat back in the day. It was a little briefcase thing that the arcade repairman would take around with them. Well, someone's recreated that, but they have made it into a device that is modern and uses FPGA and all that logic. So it's very cool. So we have two Centipede boards that don't work. The one that's not currently on the bench, I have tracked down that one of the ROMs is not being accessed. It's ROM 1 on that one. And I see that there's no, out of the LS139, which is the address mux, or address decoder, I should say, LS139, yeah, that takes in 2 address lines and puts out 4. So it's a decoder, takes in 2, puts out 4 lines, and each one of those lines is telling each ROM to send its data. And our ROM 1 is never being accessed. Now, on a good working board, according to the internet, all 4 of these ROMs should be accessed all the time. So they all should show active on a logic probe. Of course, they're accessing at 1.5 gigahertz or whatever, so it's not really accessing all of them all the time. It's only accessing one at a time, but it's so fast you can't tell the difference. So I ordered a new 139, and that one will be here on Thursday. So until Thursday, that board is on the back burner until we can get that chip and see if that fixes it. This one is even more broke-a-did-did. Okay? This one, all right, awesome. What's up, Todd? It is Todd's birthday today. Everyone give a happy birthday to Todd. Hell yeah, hell yeah. Hope he's having a great birthday. Anyways, these documents exist online, and if anyone ever wants to find them, all of the manuals for all of these different arcade games can be found on xmission.com. I'll go here. So xmission.com under Atari, and then Centipede, and then we can see, oh, well, apparently it downloads them. My other computer just opens it in the browser, but that will do. Okay, get all those open. Fantastic. So now I can kind of show you guys what I'm talking about, and it's not looking through a camera. Okay, there we go. So we're still missing one. Which one are we missing? I can't tell because it doesn't show the fucking. There we go. Now they're all open, I think. Okay. Okay. Well, we do technically have a computer in front of us. It's a really old computer, though. And it only does one thing, and that's run Centipede. It's a 6102 processor, or 6502. I always say it wrong. 6502 processor. Okay, so if you guys want to follow along, that is where you can find the schematic. I would show it on the computer, but my computer is this laptop sucks, and it seems like it wants to kill itself because I have a PDF open and I am streaming at the same time. So I might just have to show you on the piece of paper. We can get the oscilloscope on here if we want to. Okay, good. Okay, so this board does absolutely nothing other than show a scrolling screen. So if we turn it on, one thing I've found, okay, so the first thing that this board does is the CPU has to run, obviously. And the CPU has a reset line. It's called the watchdog line. And that's make sure, and that's true for all microprocessors even today. Arduinos all have watchdogs in them. They're much faster than the watchdog in a 6502. But anyways, the watchdog is active low. Okay, so the logic probe is currently telling us that the 6502 is being told to reset. And it is not being told to turn on. It's not being told turn off, turn on, turn off, turn on. That's called a watchdog loop. It is just being told off. It's just being told to reset all the time. Okay? And I found that if I ground the watchdog, which makes it disables the fact that it should be resetting, I now have a high watchdog. Okay, so now the watchdog is no longer resetting, and it's actually not resetting at all. And now on our 6502, we can see that on our outputs, we have something on some of them. And our ROMs, ROM 0 is not doing anything, ROM 1 is not doing anything, ROM 2 is not doing anything, ROM 3 is not doing anything, and ROM's not doing anything. All right, but our watchdog is no longer resetting the code. There is a button that should make it reset, and it does. But when I click it, it goes low and doesn't go back high. So the first thing I want to check is if this button's broken, because it could just be that when you click this button, it's not working. We can short this out again. That instantly makes it back high, but if I hit the button, it goes low and it doesn't go back high. So the reset or the watchdog circuit should be toggling all the time. It shouldn't be just staying low or staying high or not doing that stuff. So anyways, if you're following along, we are on side 2 of sheet 1, side B. Sheet 1, side B. And this is the microprocessor section. So the watchdog gets its 5 volt into a NAND gate, and then goes to pins 2 and 3 of a counter. Okay, and then that counter is like 4D flip-flops. If you've never taken a digital logic class, I have an undergrad in computer engineering, so this all just makes sense to me. But if you've never taken a digital logic class, you're like, what the fuck, right? So here's the reset switch. There's 2 transistors, and that's tied to pin 6 and 7 of the counter, which is just D flip-flops. And the output of that is going through a NOR, or a NOT gate, and then going into the reset pin. Okay, so this is what the reset line, this is what feeding the reset line. And we see one single line that goes woo, all the way over here to the other page. Yeah, the cat box. Don't ask me why they call it that. Okay, and then over here, this is the signal we should be getting for V blank. It's V blank not. If you didn't know, in schematic world, if it's got a line over it, that means it's the opposite. So if it says V reset with a line over it, that's the opposite of V reset. So if reset is high, V reset with a line is low. It's always the opposite of what the actual V reset signal is. So out of this fancy LS175, we should get a V blank, and that is on pin 11. And that is coming from our synchronizer, and our synchronizer is what actually makes our picture. So this is the picture portion of the circuit. And this is how most of the really early Atari boards work. They have this fancy all these counters with synchronizers, and that's what gets the board up and running. So that's like the very first things that need to work is this stuff. And we obviously have something that's not working. We just got to figure out what. So let's take a look at the LS175 pin 11, which is V blank. And it gives us this code. Let's see if I can change my camera angle to make those lines go away. I'm sorry about those lines. I think it's due to my LED lights above my desk. They look really bad on my screen. I don't know how bad they look on yours if they're just scrolling down like that. Let me see if it looks that bad on my phone. Okay, it's not so bad on the stream, it looks like on my phone at least. Okay, anyways, all this blue crap is telling us if we use the cat box, which we don't have because they're probably $1 bajillion and they only made them in 1982, 1981, this is the values we should be getting out of these points of the circuit board. So we get no picture on this board, and if we do, it's just scrolling really fast vertically. So, they bad, says Grass Puddle. Okay. I really don't know what I can do about that other than get new fucking lights or get a new camera. Because it's just like the frequency of my camera and the frequency of the lights is just slightly shifted. I could put a polarizing lens over my camera and shift the frequency, blah, blah. Anyways, okay, so why is our reset circuit not flip-flopping? It's not flip-flopping because nothing's telling it to flip-flop. And the thing that's supposed to tell it to flip-flop, other than the button and the watchdog circuit itself, is pin 14, which is V blank, okay? So, the watchdog circuit is not watchdogging. It should be flip-flopping every so often. And that's due to this NOR gate. So we have not watchdog and watchdog out of L8, right? And if those are the same, then it puts the opposite out. If they're not the same, then it puts not, you know, that's how a NAND gate works. But anyways, so just straight off the bat, our watchdog isn't watchdogging. Why is that? So I gotta find where the not watchdog circuit comes from because it just appears out of microprocessor land. So let's find where we can find not watchdog somewhere else in this circuit. Probably take us a long time to find because it's probably in a very random place because it just needs to be something that... Oh, does it get that from the Pokey? It might. It might get that from the Pokey. Okay, because Pokey's a random number generator. Okay, let's see. If I turn this off and I put our Pokey back in, it might get that from the Pokey. That might be our problem. If that's our problem then. Nope, it's still low. So it's not the Pokey's fault. Okay. I just need to find where this not watchdog comes from. Ah, here it is. Here it is. F3. It's an OR between F3, 9, and 10. Not watchdog. Okay, so let's find F3. So this is the nicest part. Oh, yeah, my screen chat is stuck. Thank you. That's from last night. I always have to refresh it or it doesn't. Phil, they are. I can actually give you guys a link to where you can get them. I got a paper copy with, thankfully all this paperwork was in one of my Centipedes, and it's all original, which is so awesome because I have paper and we can get, but this website, you can go to that website if you want to look at the schematics with me. And then under this PDF Arcade Atari, and then go down to Centipede, and we're looking at, this is sheet 1 side B. So sheet 1 side B, right here, and it downloads, and you can open it, and that will look exactly like this, and it's a really high res image. TheXmission.com is a great resource for this stuff. So. Yeah, hopefully, I'm sorry about the light. I don't know what to do about that. It's, oh, is it this? Does that make it better? Or worse? What if I turned this on? Does this make it better? That makes it worse. It's so annoying. And cheap shop lights, I guess. And cheap camera with cheap shop lights is our problem there. Okay, so our watchdog isn't watchdogging. And we want to look at F3 pins 9 and 10. So the board is currently on. So F3, and the way that these boards are laid out is in grids. So A, B, C, D, E, F3, which is an LS32, which is just a bunch of, which is just digital logic OR gates. And that is 9 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is high. And 10 has nothing on it. Oh no, they're both high. 2, 3, 4, 5, 6, 7. Oh no, 9 and 10. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9 is high. And 10 is just not connected. There's nothing there. And so 11 is high because 8 is high. 10 is the output, or 6 is, fuck, sorry. Reading goddamn schematics. Yeah, 9 and 10 are the inputs. 8 is the output. So 8 is high. That's because 9 is high, and 10 is nothing. There's absolutely no signal on 10. So that's weird. So where does 10 come from? 10 comes from write to. Comes from this write command, write to. And that comes out of A7, which is a NAND gate of the 6 megahertz clock, 10, 12, and 13 into A7, which are all just write commands out of this LS244, which is should be coming from the clock. So the clock signal comes into pin 11, and we get an output on 9, and an output on 7. The output on 9 is what is affecting our... Right. So let's see... So the hard part about these schematics usually is that once you get into muxes, it's much harder to just read what is going on in there because it's a bunch of address ones and zeros and you can't really read the ones and zeros unless you like run oscilloscope pause, and you can't like do that real time, right? So that is where we're going to start. We don't have anything on pin 10 of this F3. So let's go back to A7. Let's go back to A7 pin 8, and let's keep going back until we find a signal. So A7, that's going to be way... A7, pin 8, 1, 2, 3, 4, 5, 6, 7, 8. And that pin's also just completely dead. It's not a high signal, it's not a low signal, it's just... Oh no, wait. It's because the fucking thing's on. 7 and 8. Is that what I said? Yeah, A7, 8. Yeah, it's just nothing. I've never had a pin just be nothing. It is so bizarre. But it is. It's just... Like, even ground is low. It's just floating. It's somewhere in the middle. What does that look like on the oscilloscope? What does nothing look like on an oscilloscope? What is nothing on a digital... Let's see. So that's 500 millivolts it's went into. So if we put that to 1 volt, it's like, it's not high, it's not low. It's just like in the middle. Hey, hot cows. Yeah, it's something weird. Now, let's check and see if it's just... Well, if it was shorted straight to ground, it would just be low, right? And it's not even low, it's just... It's something. So let's see. Pin 7. Yeah, it's not shorted to ground. Let's see, what does it say voltage-wise is there? It says it's a 1.5 volt DC. Not high, just hanging out at a 1.5 volt. Very strange. Okay, let's look at our inputs to LS20 and see if it's that way over here. So that is the 6 megahertz clock is on pin 9, so we can check that with the logic probe. We'll hear beep, 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 you know. So A7, pin 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah! Nothing there. No clock. No 6 megahertz clock. Well, that's a problem. Is there 6 megahertz clock over here? No, there's not. Is there a clock over here? Yes. So if we look at our 6 megahertz clock, ground, and put that there. And there is a 6 megahertz clock there. It's just really low voltage. I feel like. How strange. Okay, let's trace the 6 megahertz line, which I think is over here. Yeah, okay, because that says 500 millivolts. What if we do 12 megahertz? Yeah, that's still 500 millivolt. You guys are answering the question. I don't even have to do it, but yes. Okay, and there's our 1.5 line. And that looks good. So, I don't understand why the logic probe doesn't seem to see the clock signal. Doesn't make any sense to me. Is it just too fast for it? Okay, there's the 12. Can we see the actual clock signal, like straight from the clock? The clock goes into a leg of Q1, so. Yeah, there's the clock, the raw clock. I mean, if the oscilloscope shows it's good, right? Do we see it over here? Yeah, we do. So there is a 6 megahertz clock. Good night, hot cows. There's the 6 megahertz clock on that pin. It just seems like the voltage isn't high enough, though. Like, what should the voltage be on the clock signal? Like, what should the peak-to-peak be? I'm asking AI. Yeah, it should be 5 volts peak to peak, I think. Because if we look at the clock circuit, the clock is just 5 volts through a 10K resistor, and then the clock. And we can see that right at, like, we just touched it right where it comes out, so. I mean, we can get our other board up here and see what it looks like. I guess. Anyways. Okay. So, let's assume the clock is good for now so that we can continue on here and look at the other signals, because we might just find our smoking gun right after this or something. Right? So we have 3 other signals that go into A10 other than the clock on pin 9. On pin 10, we have nothing. 12, low, 13, It's going to be low too. And that's going through K3. K3. Which is a NOR gate on 8. So this should be high. Or that's 9. 8 should be high. Oh. All right, K3. Am I on K3? Yeah, K3. It says K3 is a NOT gate. 1, 2, 3, 4, 5, 6. Oh, 8 is low, which is the output of 9. And 9 is high. Yeah, so that logic checks out. So 9 is high, so 8 is low. That is how that's supposed to work. Okay. But this... So what we need is this right gate to go high, which is at K8. Because when it's high and the clock triggers, then it triggers the watchdog. But it's not, it's just staying low all the time. And why is it staying low all the time? Well, it's staying low all the time because there's no signal coming out of B1. And B1 on pins 11, I think there's 10 on each side of this chip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This should be the clock. And it is. And 13. Thirteen 13 should be our clock that the CPU makes. So there's the clock the CPU makes right there. Oh no, that's read-write. Okay, so there's the clock the CPU makes, and that goes into 11 right here. And that's there. There's the clock. You hear it beeping. And the CPU should be toggling read-write on pin 13. And it's not. But it's not because, oh no, it's high. So, and that should give us outputs on, so here's B1. Here's the outputs that we care about, which is 9. So 9, B1 9, which is going to be this pin. Ooh! 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a signal. And that sounds like a happy signal. But to get through our gate here to make this signal high, so this is a NAND gate. So if all of these are not high, then it's low, but it's not NAND, so it should be high. And I'll make this low and that high. Hello. Okay, so the output on 12, let's see what the output on 12 of that is. It's K2. K2. Here's K2. It's a 74LS10. 74LS10. And it gets the input from 9 on pin 13. There it is. Beep, 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 beep. Which is the clock. Okay. And it also gets on pin 1. That's low. And on pin 2, it gets a signal there too. And that signal is just says 1H. So 1 horizontal. And it is getting that. And 1H is way over here. somewhere. Yeah, that's right here, 1H. That's in the synchronizer circuit. So 1H comes down, goes through this P load. But somewhere we're clamping that over here to that one. So, all right, so we have two signals that are up and down, and one that is low all the time, which is K2, K2. Which is this line out of, which is the read-write line. And the read-write line is not doing anything on the CPU. It's just not doing anything. So let's see if we can swap the CPU and see if that makes it do something. Because I have other CPUs here that I don't think are broken. They could all be broken, though, I guess. So is the read-write line doing anything on this one? 34, 20, 40. It's high. $34. So that means pin 11 should be high. 3, 4, 5, 6, 7, 8, 9, 10. Pin 7. Is high. Yep. It's the output of that. 13. Yep. Yes. Yeah, we're doing our logic tables. That is what we're doing. I loved the digital logic class, so I'll do this all frickin' day long. We'll just go through this and see if the logic makes sense. So, I'm still sus of our clock. The clock is sussing me out. Okay. I tell you what's really sussing me out. If you're following along with us in the address decoder, A7 is a NAND gate. So it's all of these have to be on for this to give a low signal. And if any one of these is off, then it gives a high signal. Right? And at A7, pin 8, there's just nothing there. The output is not high, it's not low, it's just weird. R9 is there, I think. R10, 11. Oh, 11's not used, I guess. 12 is low. 13 is low, which means our output should be high. Because pin 9... Yeah, but pin 9 is the clock and it's like floating. Which means all of them would be low, which means the output would be low. No, if all of them are low, then the output is high, because it's a NAND. So it's the opposite of, they all have to be they all have to, if they're all are high in an AND gate, then the output's high. If any of them are low, then the output is low. But on a NAND, it's the opposite. So if all of them are high, the output is low. If any one of them is low, then the output is high, right? Does that make sense? I think the gate is bad. Because the output is not high, it's not low, it's just BS. It's a 74LS0. Do I have one? I have lots of random 74 series chips, but I don't know if I have a 0. Just a... Same for LS13. $13, 7490, 7462, 161, 184, 175, 11, 20. Yeah, I don't know. I don't think I have one. I've tried to make an extensive supply of random chips, but it's lacking still. I have a 74LS16. Yeah. I never have the one I need, by the way. That's just the case. Dude, you know how many gates are on this thing? You could have said bad gates 4 hours ago. And that's probably true for every board. It's probably bad gates on every board. There's just 60 gates on here. Smart Alec. I just don't understand. I've never seen that before. Why is that nothing on the logic probe? Okay, if I put on the oscilloscope on that pin, what do I see? Yeah, that's gross. It's like just hanging out at, let's measure that. Peak to peak? No, let's... amplitude. Yeah, look at that. V amp is like... Why is this cutting off? I'm sassing your ass. Yeah, V peak to peak should be like let's see what it is on the clock. $2 on the clock, which I think is right, because it's... And the output of this LS04 is 200 millivolt. And it's just like being weird. But the input clock is 2 volt. The input clock peak to peak is 2 volt, and that should just be the 6 megahertz clock. But over here, the 6 megahertz clock is 2 volt. Okay, so that's the same. That's the same. But why is the output not 1 and not 0? It's just like something else. Okay, yeah, because if I had an yeah, so this NAND should be low only when all the other outputs are high, and high in every other case. So should be low only when all inputs are high. Here's pin 10 is low, pin 12 is low, pin 13 is low, so pin 8 should be high, and it's not. It's not. That has to be one of our problems. That can't be how that's supposed to work. So let me disconnect the board here. Let's do just an inspection on the bottom. I mean, the pins look fine. 74LS0. I have 74LS00, don't I? Is that different from 0? Oh no, that's a 74LS20. Oh yeah, 20, okay. 74LS20. I was looking for a 0. Did I have a 20? Might be upstairs, I'll have to look upstairs. Oh, I have a 21. Oh no, that's not it, that's a MC chip, fuck. 74LS21. 7420! Is this it? 7420. Yes. This is SN74H20N, so this isn't the low. I think this will still work, it's just not the low power one, it's the regular. You guys can tell me if I'm wrong. This is an SN74H20, replacing a 74LS20. And I'm pretty sure when I asked the internet, it said I could do that. Can I replace a 74LS20 with a SN74H20N? Both chips are dual 4 input, but they belong to two different families. Mine is the high-speed TTL. The SN74H20N typically consumes more power than the 20, If your circuit is heavily loaded or running on batteries, you may need to check your power supply can handle the increased current. Okay, so anyways, I'm going to piggyback this on that and see if that changes anything about how our circuit's operating. So we'll just put that like this. Let's crimp its legs down so that it's pretty like that. Let's see what its output is now. See if that changes anything about its output. Okay. Hey! Now it's doing something. Is our watchdog watchdogging? No. Get nothing over there. What is going on with my... Huh. Don't seem to like that very much. Oh, it's because I'm being a dumbass. That's why. Oh, the board plugged in. Dumbass. All right, let me plug the board in and not just read floating grounds and be like, I solved the problem. Get that back on there. Okay. Now let's see what it does. Look at that, it's high now. Okay, does that change anything about our output? I'm not sure if it's going to, but I guess we can at least look. No, it doesn't. Because our 6502 is still just sitting low. It's not. Okay, so we have high now. With that piggybacked. Hey, Attic. So we have high now coming out of our A7. And that should be coming down to pin 10 of F3. So pin 10 of F3. 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is, pin 10 of F3. And pin 9, so they're both high now. So 9, 1, 2, 3, 4, 5, 6, 7, 8. 9 is high. 10 is high. So 8, this is an OR gate. So it should be high, and it is. Okay. So we have high on the watchdog. That makes sense now to me. We have, oh, damn it. We have high on the watchdog not. So that's LS8 or L8. L8 pin 1. Yep. And 2 is also high. So 3 should be low. And it is. And it is. Okay. And that signal goes into L2, which is our counter on pin 2 and 3. Low, low, yep. Okay. And our reset button comes on 1, 2, 3, 4, 5, 6, and 7. And if I hold this button, yeah, that button is working fine. It triggers it. Triggers it. Nothing on the screen though. And we're still just held in reset. So if 2 and 3 are held low on the counter, which is a LS90, so that's L2, 2 and 3, low, low, and 6 and 7, low, low. We have pin 14, which is high, and that is coming from our V blank, which I think is supposed to be a signal. I don't think it's supposed to just be high. I think there's supposed to be some sort of frickin' signal there, because it's pin 14 of L3, wasn't it? No, some shit. Was it L2, pin 14 of L2, yeah. That's what I said, right? Sorry. We're sniffing it out. Okay, so this is the enigma part of the circuit that I'm really not sure about. This is the enigma part. So there's this special chip that Atari makes in what is it? P4? Yeah, P4. It says it's a 82S129. I don't know if you can buy those, or I'm not really sure what that chip does, but it takes in all the clock signals and all the counter signals for the display, and then puts it out on 4 lines that go into this LS175, which I need to look up what that logic chip is. And then that puts out all these outputs. So, ooh, something I haven't looked at is this guy down here, this 9 that comes in. I need to see if that looks good. So let's see. N1. N1. Just this guy all the way over here. 10 and 11.
Looks to be working okay.
Looks like we got an in and an out. Okay. And then on pin 9 of N4. Oh, that's that output. That's one of the outputs. That sounds really bad. Maybe that's how they sound, though. I honestly don't know. That's the weird one. Okay, and then N4. N4 on pin 9. Yeah, there's the clock. There's the clock. Bomb has been planted, right? So I know these counters go bad, this N2 and M2. So we're gonna look at the outputs of those counters because they give us all of our H signals, and we're gonna see if they double each time. So N2 and M2. N2 and M2, they're right here in front of me. And I actually have replacement chips right here because I already tried to replace them. And it didn't seem to do much. But N2 pin 14 should be N2, what did I say? N2 pin 14. This is our quickest clock, I think. So let's see if this goes, let's do this, and then I'll show it to you guys here. So that looks happy, right? That looks like a regular clock or H signal. So then we go back to 13. So that's 14, that's at 378 kilohertz, and that's 8H. So now we go to 16H. 188 kilohertz, so that sounds right. Now 32H. 95 kilohertz. Now 11H. We gotta go back out again. $47. So was this 80 some? Yep. 47. Yep. Okay. That chip looks to be working okay. And then we go down again on pin 14 of M2. It's 15 kilohertz. So was this one 30? Oh, whoops. Yeah, 47. $15, and this one's probably like 7, right? That should be, this should be 14, and that's 15 kilohertz. And this one's 15 kilohertz. I don't think those should be the same. That is 128. Oh, no, wait. Yeah, that's 128 on pin 14. And pin 13 should be 256H. And it's the same. Okay. So I don't think that's doing what it should. And if I piggyback it, I don't think that will work because it's still getting the bad signal, right? That was M2. Right? M2? Yeah. M2. What does it look like if I piggyback it, I wonder? Just to...
So 15 in and 15 out. Huh.
That just doesn't make sense to me. Because all of these are decreasing in frequency from, we start at 8, 16, 32, 64, 128, 256. 256 I would expect to be the slowest one, and it should be half as the speed of the one in front of it, which is 14. So 16, 15, 14 is 15 kilohertz. And 13 is also 15 kilohertz, if I'm reading this right. Am I reading it right? Yeah, I think so. 14 and 13. I don't think those are supposed to be the same. What do you guys think? Because they're not the same on any other pin. If we go up to this one, there's 14, 13. You'll see it gets smaller each time. 12, 11. And then we come over here and do this one. 11. Smaller. And smallest. And it's the same. So, we can test this. Well, V only goes up to 128. It doesn't go up to 256. But we can see that everything changes up to 128. What is 120? What is 128 on V? That's on N3. N3. Pin 11. Yeah, look at that. 128V is 250 hertz. We do have one more counter at P2, yeah, all the way down here. And that should be our very fastest signal at 14. At 14, right there. Yeah, and it is. That's real fast, right? And then 13, it should go down. Yeah, so that one is... Well, we have to readjust, or it's not gonna measure it right. It's really fucking annoying. Yeah, so that's 6 megahertz. 1H is 6 megahertz. And then the next one should be half that at 3 megahertz. The next one should be half that. At 1.5, and it is. And then we go to N2. And that should be half that, so... And that number's not right, because it's... ...12 megahertz on N2. Does that make sense? 11 was what? 11's 5 megahertz. Oh, I'm fucking reading this wrong again. God damn it. That's the fucking raw clock. This should be the raw clock. Is this the raw clock? Yeah, there it is. There's your raw clock. And that's going to be straight up like 6 megahertz or 12 megahertz. Yeah, that's your raw clock. Damn it, Tristan. Okay, so this one, let's get back out to that. So that's 300 kilohertz. And that takes us from 700 kilohertz. So, yep, that checks out. 700 to 300. And then 300 to probably 150. Yeah, approximately. And then 150 to 75, 95. That's fine. And then 95 to 47. 47 to 15, and then 15 to low 15. Oh no, there it is, 15 again. So yeah, that's not how that's supposed to be, I don't think. I don't think that's right. I don't think so. So we'll we're gonna have to take him out and socket him, and we'll do the same thing up here with A7 because that's definitely not right either. We'll socket him. So let's get a marker or something so that I can remember what I need to take out so I don't take out random shit. Random shit. Also need to find my damn chem wick. Because I had some. And I don't know where it went. Because I am a master at losing shit. I think it fell behind somewhere or something. I had a brand new thing of it that I haven't used yet. And it's disappeared. Anyways, let's get this. Start this iron at 350, or our solder sinker at 350. Anything higher than that's probably overkill. So that's off. So let's get to replacing A7 and M2. Yes. Okay, so let me clean my tool out here. Moo, as hot cows would say. Moo. Okay, I think that's cleaned out. Yeah, it's clean. All right, cool. Okay, so now I'm going to take this board and we'll desolder those 2 chips. Boo. All right, let's see if that did it. That should be 1 done. Let's see. Legs look pretty. Removed. Is it? There it is. And we didn't pull up any traces. There's the 74 LS20. Yes, I have a spares and strikes that I need to do out in the barn. Haven't gotten to that yet. That's on the list. Okay, and M2, so let's get M2 out of there. Real quick. Yes. Where did I put my little picky? There it is. Some of that on there. Thankfully the solder flows really well. Probably because it's actually leaded solder from the 80s and it's not that lead-free shit we use today. Don't get me started on all that. Okay, get this back on. Why do I always turn it off? I have a habit of turning it off when I know I'm going to need it in 5 minutes. Now I gotta fucking wait. I have a habit of doing that. If we put a new chip in here and it's still the same, I don't know what I'm missing on that, but I don't understand something. Some of that logic is not making sense to me. This is still the same after we do this. Let me get the iron on because we have to put our socket in here. Sockets. Moo. Okay. That one had a few that didn't look like they wanted to come off. Yeah. The ground and the farther one. So let's turn it up real high. And we'll put new solder on those 2 pins. And we'll hit it again. And then it should give for us. So a little new solder on there. I know you guys can't see this, I'm sorry, give me a second. I didn't expect this to... I didn't really want to change camera just for this because this board is so big, it's not like you can really see much anything anyway, to be completely honest with you. Thankfully this Heiko heats up pretty fast. So, not too hateful. Okay, that got our 5-volt line in our ground. Good to go there, so let's see if that one pulls out now. That's gonna be this guy right here. I think I see one more leg that didn't come out, yeah. 3 in, 3 in, doesn't look like he came out. 4 in on that side. He's got some solder on top, so let's tin him and redo him. Because the last thing we want on one of these really old boards is a messed up trace. Think I got it?
Nope, something is still holding on.
I think it's you back here. Yeah, it is. 4 on the inside right there. I see him. I see you, dog. I see you, dog. Did I leave it on this time? No, of course not. That would be too smart of me to do. Why would I do that? Should come up now. I can't see anything else that would possibly be holding it in, but there might be something. And we ran off with our chip puller, didn't we?
It's gonna budge. No.
Where do we put our chip puller? It's just here. There it is. I have a lot of chip pullers. This is my
good one though. Come on, let go. What's still holding you in, huh? What's still holding you in, man?
Let's just run around each one real fast at Mock Jesus. There we go. And look at that, no burnt traces. Whenever I use heat, I always get bad burnt traces. That way we don't get any of that bullshit. And this is a 16. Those are two 16s, I think, or 16 and a 14. 16 and a 14. So let's get a 16 and a 14 socket. 16, 14. And we'll socket those chips. We'll find out how wrong we were on this very shortly. Man, these boards are so big. I need such a bigger workbench than what I currently have to work on these, man. It's just not big enough. I just got too much shit. Okay. Mm-hmm. You gonna stay? Good. Okay. There it is. Ta-da! Did we put that one socket in backwards? Yes, but I don't give a shit. I don't give a fuck. Flying shit. So here is our new 163. It can go right in here. And then our new 7420 can go right there. And let's see what it does now. Is it gonna be any different? Man, I hate this edge connector, man. Wish it wasn't so tough. All right, yeah, so that guy's replaced. That's the 163 replaced. There's the 20, so that's the new 20 in there. That's the new 163. Yep. Okay. Nothing exploded. That's good. And our output on this is still high. So that's working now. And let's see if our output has changed on our 14 and 13 over here. If it hasn't, there's the 15 kilohertz. No, they're both 15. That doesn't make any fucking sense to me.
15, and 15. Unless the 256 just doesn't rise. I don't know. I honestly don't know. And that 256 goes into N1. N1 at 11. Yep, there it is. And it comes out on 10, which should look the same but flipped. Yep. And it is. And that goes into our clock and stuff for 256. 256H. So we still don't have a game, but we did fix something because that chip was definitely bad. We're just still, our reset circuit is not. Oh, we can't actually get it to do anything now. What if I ground it though? What if I ground it with something? Then it goes high and it doesn't switch still. We get no switching. And the watchdog should be triggering like every millisecond. It should be like pop, 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 pop. You like that? Why not though? Why is it not triggering? It's not triggering because the CPU is not sending out read writes. And why is it not sending out read writes? And I've swapped the CPU, so I don't think it's that. And we have the clock. And the clock is, let's check the clock frequency. I think it's right. It should be 1.5 megahertz. And it is 1.5 megahertz, so that's fine. And the output, 1.5 megahertz. With some, what? It's 1.5, but it's got dropouts. That's weird. I don't think it's supposed to have dropouts like that. But we swapped the CPU. And it didn't do anything to change our problem. Let's swap back. Let's swap our CPU back, see what happens. Swap it back. Ugh. And this is the, yeah, 6502, okay. Go right in, right this way, sir. Ah, that looks better. That looks a lot better. Didn't really. Still got nothing on the screen, but that clock looks a lot better. That looks good. I just don't get why H128 and H256 are exactly the same signal. I think there's no way that should be true. Why would they differentiate them if they're the same signal? Makes no sense. We have some other things we can check on the counter. We have N1, 9, and 8. Yeah, that looks like the inverse of that. I don't know what... That doesn't look good, though. I don't know what that's supposed to be. This is... It's the RIP. R1P. RIP off of the counter. So let me figure out what the hell that is. So let's look up the LS163. LS163A. It's a... No. Damn it. Get the fuck out of here. Stop signing me in. Yeah, so the LS163A is a synchronous 4-bit binary counter. And pin 15 is the ripple carry output. Oh, no, wait. Yeah. So, pin 15. That one, there's that one. Wow, these ripple carry outputs look weird. I don't know what that's supposed to look like, but that one just looks really weird. But that's our replacement chip. I don't think it's wrong. It's doing what it's told. So, and that's coming off the RIP of P2. Ah. RIP of P2 is going into ET and EP. Attic knows what's wrong with it. It ain't got no gas in it. Yeah, I feel like our counter's messed up. Because it's not... That's what I have to say. Because our main problem is that our watchdog isn't watchdogging. And our watchdog isn't watchdogging because it's not being told to go high at any point. It's not being told to go high at any point because the read-write line of the CPU is never being activated. And then as soon as it is, it starts going. Because it will start. LS244.
What does an LS244 do? Octal non-inverting buffer and line driver with 3 state outputs designed to improve the performance and density of 3 state memory address drivers, clock drivers, bus-oriented transmitters, receivers. It contains 8 buffers organized into 2 4-bit sets, each with its own active low output enable. Acts as a buffer, strengthening signals to drive heavy loaded buses. So it just takes an input and gives an output. Takes an input and gives an output. So on pin 11, it takes an input and yeah, so it's just a pass-through. It's just a pass-through. So 11 should give you 9 and 13 should give you 7. So if 11 is a beeping signal, beep, 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 which is the clock, then on 13 should be a beeping. On 13, it should be a beeping signal, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And it's not a beeping signal on 13. That's it, right? Oh no, it's 9 and 11. So that's 11. And here's 9. Yeah, so that's working. And then 13 and 7. So 1, 2, 3, 4, 5, 6, 7 is high. So what does it do on the output? 13, it gives a high. It says hello, it says hello. So that means K3, 4 is low. And it is. So that means K2, 1 is low, and 13 is beeping, and 2 is beeping. So that will be, so that is NAND. Oh, come on, phone. That is a NAND, so 12 should be high. 12 on K2. And it is. And that goes over to pin 8 of K3. Wait. 8, pin 8 of K3. Oh no, pin 9 of K3. And then that goes through the NAND gate to pin 8. And that makes 13, 12, and 10 low. So let's see. This is a OR gate, an OR gate, and this output on A78 is high. So if we go to F3, now that we fixed that, because that was broken, remember, that was neither low nor high. F3. F3 is this guy. He is AND with 9 and 10 and 8. So 8. That is our output. 9 is an input, and 10 is an input. So they're all high.
But the one input to that is an LS42, which should be a signal. It should be a signal on a bus, not just a high signal. It should be like data. And it's not data. But it's not data because the watchdog isn't resetting. See, we're in a fucking constant loop now. Hitting the button doesn't make the thing stop resetting anymore now. What if I short it? Does that make it stop? It does. And now do I see data? If I hold the reset? I do. Okay, if I hold the reset, do I get something on screen? No. Bet you I get something on screen on my computer, though. It's just scrolling really bad. I bet. Because that's what it was doing before. It's just scrolling really bad. But as soon as I let go of that, oh, now we're staying high. So now it's not resetting at all. That's the other thing I can get it in. I can get it in a state where it doesn't reset at all. And I see data on all the pins. Well, some of the pins. ROM 0 is not being accessed. Oh, none of the ROMs are being accessed. They're just kind of sitting there. All confused on what the fuck's going on. They're like, what the fuck? Help me, help me. But now I should see data on the decoder, which is the LS42 at H3. Yeah. On 13, 14, 15. I don't. And that's coming from 22 on this. So that's 20. Oh, we died again. We went back low, huh? No, we're high. Why aren't we running code? We're just frozen. No code. No code is being run, but our reset isn't telling it to reset. Do we have clock? Yeah, we do. So why the fuck aren't we trying to run code? Why are we just sitting here? Not doing a damn thing. We outputting this clock? Yeah, we are. So why is address lines not doing anything? Why is all of our address lines just sitting idle? Why is that? So the only other thing that the address lines are connected to is the pokey. So our pokey could be pulling the line down. Take the pokey out again. Let's get you back to the screen because you're not going to see anything on that screen for a while. We're back to having nothing on the lines. That's because we haven't held the reset low. So we still got to figure out why a reset won't reset. But there we go. Okay, so now we have dater on 22. We have dater on all of our lines now. So if we go Our VSync is still mad. This is the maddest board. ROM 0 is still not doing anything. ROM 1's doing something. ROM 2's doing something. ROM 3 is not doing anything. And ROM is doing something. Isn't that it? J2 on that? That's like what selects the ROMs. Change your cam back. I don't think you're going to see anything on that screen for a long while yet. Yeah, that's coming out of J2 up here. 13 and 14 are inlines on that. And then our output lines are 9, 10, 11, 12. So I on both of these boards, I've been led to this 139, and I don't know if it's because I don't understand how it works, or if it's because something else in the system is not working and I'm not understanding it. Because an LS42 is a decoder. It takes 4 inputs and gives 8 outputs. And all of these lines should be doing something. On the output side, I'm seeing data on the input side. 15, 14, 13, and 12 is 12 should just be straight address 13, which is pin 23, 21, 2, 3. Ah, what's going on there? Right, because this is 20, 1, 2, 3. There's pin 23. And it is not making it all the way over here to pin 12 on the decoder. Pin 12 on the decoder. So 8, 9, 10, 11, 12. It's just high. Okay. So that is that's something that's not good. Because that is the LS42 at H3, which is what we've been probing this whole time. Oh no, we're going wrong. Is that right? Also at H3. So at we should see 16, 15, 14, 13, 12. Yeah. At 12, we should just see address line 13, which is pin 23 on the chip. Oh, now it's fucking low again. Stop doing that. I don't know where. This is the joys of doing this. So we've definitely identified one bad chip and replaced it, because that was not doing what it should, and now it is. And it's flip-flopping. And it's flipping and flopping. And that goes into, yeah, that was our A7 that we've decided was bad. Right? Yeah, that was our LS20. That was definitely not good. And then our LS10 has a signal on 1. And a signal on 13. And a signal on 2. So on 12, it should be giving a signal, and it is. So that goes into 9 on K3. K3, 9. There it is. And on K8, it gives the opposite. Very good. And then that goes into A7, which should be $13, $12, and $10, and 9 should be the clock. And nine should be the 6 megahertz clock. I think it's just too. There's definitely a. When we read this, there was definitely a clock there. It's just like it's too fast for our 6 megahertz clock. It's there. Three volts peak to peak. I'm stuck in logic hell, it seems. Okay, are we still good on these? Yeah, okay, we're still good. So if I look at 10 on F3, F3 and 10. I see a signal. It's going up and down. And 10 I have high. So output. I feel like if I have an output that's high, listen here, and I have an output that's triggering on an OR gate. Oh, on an OR gate. So, yeah, so the output will just always be high, because the other one's going up and down, but it doesn't fucking matter if the other one's just held high all the time, because it's an OR gate. So our right isn't triggering. And it needs to be triggering to make the watchdog go, 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 go. So let's get our... This is going to be my last hoorah for the night of just trying to understand how this board works. We'll get our mostly working board and see what most of the stuff looks like on that. And then you guys can also look at a screen that isn't just garbage, and that will be fun for you. And we do know we have some bad sockets on this board, so if it doesn't just work entirely, that's okay. We're needing to replace some sockets over here for sure. Damn fucking bugs in here, man. Look at that big ass spider on there. Look at him. Big ass spider on there. They're always showing up in my basement, man. I saw the biggest fucking spider in my life the other day. I am not fucking with you. He was in this basement, and it was the biggest wolf spider I've ever seen in my entire fucking life. Okay, so if that's all plugged in, that all looks right, scissors are in right, okay. What's going on here? So, can we just do like, can we get a single fucking wire that isn't fucked up? This strand is not fucked up. Let's do that. I don't trust that other one. I need to throw it away. That one's pulled out too. Holy shit. Let's do white. Okay, let's see what this one's doing. This one's not resetting. Is our vidbox just really bad at showing us? We might not be able to do this type of signal through the capture card because it doesn't seem to do it very well. If I take this out and put this in, do you see something? No, you don't see anything. Okay. What if I put it into my TV? Sorry. Sorry about that. Okay, so that should be displaying something, but it doesn't even display anything on my... Yeah, we had a little feedback there. I do apologize. It's like you're in church. It's like you're in a church service, okay? Just get over it. See, that's what a V-Sync should sound like. Okay. I don't know why our video decoder seems to be failing us. But it seems to be playing. It just doesn't, it's really not liking our setup today. I'm really not sure why that is. I don't know. Maybe I blew out our encoder thing somehow. Let's see if we get audio. So There's definitely signal coming out of that though, because I see the signal on the VSync and HSync. But our Mr. Video board is just not doing us any favors today. And if I go into the TV, oh, I do see something on the TV. Okay. I see a bad video signal on the TV. Okay, that's good to know. Bop, 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 bop. Yeah, everything's beeping. I know. Getting garbage on the screen. I'll change you to this screen, just so you're not just looking at that. Why is this getting garbage on the screen now? Oh, let's just see if it's just... Yeah, 1 and 2 should be blinking, and they're not. When it starts up, it's... It's watchdogging. It's because it's either unable to run code or is messing up running code. Pulling the pokey does not do anything. Change the symptom. Really think it's one of these fucking sockets. Might just do all these sockets next time I stream. Because yeah, there's the game. It's trying to do something. It is there. The game is trying to run in the background. Let's see if... I don't think you guys could see that. I don't think that's going to go through the thing. And I wrote on it bad socket question mark. Because I'm seeing a V-Sync and an H-Sync signal. But I just get nothing on the screen. And I think my CPU's watchdogging. No, it's good now. It's not watchdogging. I just still have no video output. Oh, there's the video output. Oh, ROM 1's not doing anything. And ROM 0 isn't either. Yeah, I'm gonna have to do more research. I want to go to bed soon, so I'm gonna figure out why. If I should see data on all these ROMs. I think I should see data on all these ROMs all the time. But now, especially that I've gone through these, and it doesn't seem like they all are getting accessed. I don't think this can be that chip on all of them. That would make no sense. I do get a screen. It's just not a good one. So, yeah. And we've gotten a good screen through this setup before, so I don't think it's the setup's fault. That wouldn't make much sense if we started blaming the setup now, would it? And this is the one that I think is the bad 139. But now I'm not so sure, considering what we know. I don't have a 139, I ordered them. But if we plug this one in, give it a CPU. it also just gives us nothing, huh? Yeah, it's watchdogging. It has a V-Sync and an H-Sync, but we don't get a picture. Yeah, I'm calling it for now, I think. I need to investigate our setup more and make sure I'm not hamstringing myself by using this adapter board. And we might have, this board might be working. We just don't think it is because the Mr. Video JAMA adapter isn't, you know, outputting the exact signal that we expect it to. But I had this setup working one time, like when we first started. It just seems like now I see a video output on H-Sync and V-Sync, and we just see nothing on the monitor. Absolutely nothing on the monitor. Yeah, it is watchdogging. It's watchdogging. And ROM1 is consistently not being accessed. Yeah, and also I don't know how we distinguish the bad if the RAM is bad, because it could be that our RAM is bad, and that's why we're not getting outputs we would expect, because the RAM is the one that's supposed to send all this stuff to stuff like H3 decoder. On 13, 14, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, yeah, because you have all the address that comes in on the RAM, and then you have the data bus out. So I need to better understand how to even H2, how to even read the RAM and determine if it's right, if it's good or not. I don't think it's as easy as input and output. 11. Because it has all the inputs and outputs. I just don't know if it's RAM 0 pin 8 is CS. Yeah, we could. We'd have to unsolder the RAM. The RAM is soldered in. And I am buying that thing that should be able to test my RAM with the port, which is why I kind of want to just, I kind of need to, well, I really don't want to do this because I do enjoy troubleshooting these boards, but I really need that test tool to dive into this deeper without just sitting here and probing aimlessly. So I might just shelve these for now until I get that test board. And then when I get that test board, we can explore these more in depth. Because then I can actually check if things are doing what they should be and this and that and the other. I did get a few, I know something we can do tonight. This will be a lot more fun than this BS we've been doing with that. Okay. We learned some new things tonight. What we really learned is that Tristan needs to study more. That's what we learned. And he needs to get better tools for the job. Let's see here. So I know we were working on this the other day, and we gave up because we needed a mouse that worked. Well, I bought one, and I just want to see if this is going to do what if this is going to work. It should, in theory, work. And where's our little mouse device? Uh-oh. Where'd it run off to? That's going to be a problem. We just got too much shit everywhere, don't we? Yeah, we do. Too much. All over the damn place. Ugh. It's not sitting in here or something, is it? Don't look like it. Oh, Tristan. Well, maybe we won't be doing this tonight because I'm not going to be able to find the damn mouse thing. If I can't find the damn mouse thing, then... Oh, it's right here. Okay, thank God. All right, we didn't lose it. So this needs to go into joystick 1 or joystick 2, something. Try 2. I don't remember which one's supposed to be the mouse. We gots to have our power supply. Gots to. Okay. So now we'll get our output from this, and we'll plug that in all the way over here. Oh no, this doesn't take that. This takes mono, which is just our video cable. Output mono. I think that's everything. Now I gotta remember how all this works. Oh, that's saying FF because it doesn't have the damn this in it. Did we put everything back on this that we should have? Let's look. Computer. I'm hoping we did. Yes. So that's FFing because it doesn't have the flash drive in it. So we'll put that in and then. Okay. Hey, there we go. All right, we have a mouse in our Amiga now. Okay, so here's the question, right? Now that we have a working mouse on our Amiga, what I wanted to do is I wanted to put the workshop on a floppy. And if I put the workshop on a floppy, then I can burn, yeah, so I want to, I have so many mice. Okay, we got one win tonight. I'm glad we got a win tonight. So, I need to like make my top screen just game. Like you guys, I want you to look at that. And I want to put just vidbox. Up here. Can I do that or something? Open source projector. Yeah, there we go. Okay. So, DF1, it says it's bad, so. So can I just like, no, RAM disk. So what I wanted to do is write I don't know if this is gonna, it just says bad. So the floppy it isn't able to read the floppy. It seems like. Doesn't really try for very long, does it? It does click, click, and then stops. If I take it out, yeah, it goes away. Yeah. So it doesn't like this floppy drive, this floppy. I just need a blank floppy. It's really all I need. And I had that big container of floppies. What'd you say? That's crazy. So just to recap, you're checking for a component out of sync. Yeah, I have this adapter board that's adapting our signal from the Centipede board to composite that I can put into the stream that you see. And I've been struggling to get that to work. But yeah, so if I go back to 0 on that and we turn this off and on, it should boot the screen that lets me like pick shit that I put on, I think. Oh no, it's not on the right one. Let's go to 0. Yeah, flash floppy selector, that's what I want. So off, on. There we go. So reading, okay, and now we go into this, and sometimes it does this where like our keyboard doesn't seem to want to work, and I'm able to fix that by just fucking restarting it a few times. I don't know what that's about. Yeah, our keyboard's being pissy again. Okay, let's see. Why are you being pissy, keyboard? Let's get you sat in how you like. Oh, don't do that. Okay. There we go. See, I don't know why it does that, but... So let's try a game again, because we were struggling to get the games to work before. Like... Golden Axe. Let's try Golden Axe. And we'll put that... here. And then we'll go to 6. Okay, we can't do it yet. We need to save or something. So we've put that on there. Now, I don't know what we do. We restart. Isn't it like that? Yeah, that's restart. And now, can I go to 6? No, I can't. Okay, so I didn't do that right. But we can do something else, like I'll go to 5, which this should launch a game or something. It's doing something. Welcome. Space Quest. You don't have audio. That's because I don't have audio plugged in. Let's give you audio. Where's audio at? Audio's way over there, so we gotta pull those off. You should have audio now. Do you have something?
Yeah, you do. You have audio. Okay. Yeah, so this is the game we played the other day. And it's just black and white, so we only have the mono input on this. So I wanted to try a game that actually needed the mouse, and I think we had X copy on 3. And I want to put what's on drive 0 onto drive 1. So source drive, target drive. Let's see if it will do it. I don't know. It's doing something. Okay, it says it did it. So now if I boot this back to 1, oh, you guys still got the oscilloscope up there too. Get rid of that. Okay, so we go and like add Aladdin. Oh god, it's 3 discs. Like that. And then I forget, how do we save this? Because restarting it.
You look for an option like save list. Okay. Isn't there like a button? No, we're still not doing it right. So if we want to add Aladdin, have a good night. I'll be getting off soon anyways, friend. So those are now on there. And there's somehow that I save this. Yeah, because it still only sees 1 through 5. It doesn't see my new selections, which are 6, 7, and 8. Stay gold, pony boy. So he puts the last one on there, and then F10 to save. That's what I needed. F10 to save. Okay. So that should be on 6 now. Put 6 in. It's going to read 6. And it says Prodigy. I think this file's just corrupt because I don't think that's what it's supposed to say. And then if I load the next one, still doesn't do anything. Load the next one. Yeah, so let's go back down to 1 to 0 and we'll try a different file. Try a different game. What cool ass games are on this thing? We play Doom on this thing? don't think so. We can play Double Dragon. That's kind of cool. And that's just a single file, so we'll put that into 6. And then we'll save. And then we'll go to 6. Oh, that's messed up, huh? Let's go to restart. It's still messed up. Huh. Weird. Oh, no. There it goes. See, a lot of these games say they're one thing and they're not. Like, this isn't Double Dragon. This is something else, ain't it? It would say fucking Double Dragon, not Arclight or whatever the hell that said. Unless that's a company that made it, that might be the case. Oh, yep, there it is. How do I move? It's counting down. Oh, it's probably the joystick. It probably wants a fucking joystick for this game, don't it? Yeah, it probably does. What's a mouse game? Make a 500 mouse game. Okay, yeah, let's try that. Let's try Lemmings. Let's see. So we'll put this back to 0 so we can go to the thing, and we'll restart. No, bring us back here. And we can go to L. We don't have Lemmings. Populous Dungeon Master, maybe? Oops. Where did I get this fucking thing? It doesn't have any of these cool-ass games. Oh, there's SimCity Amiga? No way. Let's see if I can find these on the computer real fast. I want to play SimCity Amiga. So let's see if I can find that and add that real quick. SimCity Amiga ADF. Here we go. Okay, I hate websites like this because okay, this is taking us back to that Amiga collection that we already were looking at. So we can go to show all. Okay, so sim. Oh my god, this thing is so... I do not need to load all that, holy shit. That's better, that's what I want. All right, Sim City. Yes. It's a single ADF. Okay, we'll try that. Extract. And we will copy it onto this. Under S. Fuck. Sim City. And then paste it in here. The file, that's only 880 kilobytes. That's really the only one. I thought SimCity would be multi-disk. For sure. Anyways, I guess we'll try it. Is that on 0? Yeah, okay, good. So we go to S now. SimCity's on here. And we'll put that under whatever this is. We'll put it in 5 and then reboot. We'll go to 5. It's doing something. I think. I really don't know what it's doing. It's jumping all over the damn place. Usually it just goes, oh, there it is. Hey, look at that. We have a mouse that works. How fucking cool is that? Okay, it's loading the game. I know it's in black and white because we don't have the fucking, like, video adapter to put this into You guys excited to play SimCity? I know I fucking am. Oh, hell yeah. Trains, parks, commercial. Need to build some roads. Is this water? How do I, Oh, it's just to the corner of the screen. Okay. Where does the road come into our city? Oh shit, I just minimized that. Bring it back. Or did I just close that window? Am I just opening another SimCities? Are 2 SimCities about to be running? Yeah, it's... I really fucked it up. Okay, oh well. So let me boot back to just workshop real fast. Okay, so... Please, what? Please replace volume. It's there, man. Oh, does it want the next one? There, I loaded it. It's loading. Ah, okay, there we go. This is the info I want. Because if I do a eBay listing, I want to have this info, which is how much RAM is on it, info. Oh, that's not how you say it. Let's clear. Ooh, it sees Workbench 1.3 on DF1. So it says DF1 is also Workbench 1.3. And that is what I wanted to be able to do. So now, if I disconnect the GoTech and I re-plug in our regular floppy guy into where he's supposed to, to his home, I wonder if it reads the disk and loads up Workbench.
It does. We fucking made a floppy disk. We made a floppy disk. Look at that. So our floppy drive does work, and we have a floppy disk with, there it is. Time and date's fucked up, but okay, so Xcopy worked, and we made a So what, I know a lot of people sell these floppy disks on eBay. I could just make a shit ton of like Workbench 1.3s so that people can get their machine working again, and just put it on floppies. Look at that. It fully loaded it. There's Workbench 1.3. So now I can do what I wanted to do, which is leave the original floppy drive in here and run and have the GoTech on the outside. So this can all go back together now. This is, fuck yes. How fucking cool is that? So now I can do a veil in here, and it will show me, yes. I don't know how I close stuff in Amiga World. I have no idea how I close this window. How the fuck do you close windows in Amiga World? Does anyone know? Like right click or something? Okay, so now I should be able to plug this one into the outside drive that I purchased. And if I start it up again, the GoTech will doesn't seem to like it when this is plugged in. Is that what's going on here? So what I can do now, that I can Xcopy this stuff to this drive that we know works, is I can just make a bunch of floppies. And I have a thing of floppies. Well, I brought a thing of floppies down here. That's how I got that one floppy. Or maybe I didn't bring the whole thing down. I just brought a floppy down. Okay, so now if I plug this into here, what does it do? Does it see it as a thing? Yep. Oh no, it's still loading. It just loaded extras. Oh no, that is what I put in there as extras, I think. So if I go to 3 now, it goes away. And it's thinking.
And now it's Xcopy tools. But what if I go to 0? Can I run 0 from this screen? Yes, you can. So if I do this, this runs the manager. Okay, so we can do everything from in here. All right. Fuck yes. Okay. And then we can put, games however we want to do them. And then we can go back. And we can restart. And it will load. It always loads from the 0 disk. So it'll load that. It does take it a while to load, which is going to be annoying, but I just really think it looks best with the computer case, the original floppy in there. There's FF Manager, so now if I go to, what did we have? We had SimCity on 5. We can go to 5. And there it is, SimCity. Fucking cool, man. So I do want to buy one more thing because I hate the fact that this is black and white because I'm using the mono output. I need to get one of the adapters to give it the serial out and then, or the composite out, and then this project will be done. Which it's been, on the sideline for so long, so I had to get this mouse. So that's awesome. That's awesome. So what do I need? Like an Amiga 500 video adapter, Amiga 500 video out. DB23 to VGA, that's probably what I need. DB23 to DB9. Okay. We are chilling now. Hey, do you know we need more commercial zones in our town? I don't know how you get where you have like your starting thing. Do you just do a road from the edge? Like if I just do a road over here on the edge of the screen, does that start people coming in? Oh, fuck. And then do residential. And then we give do a coal plant. And then it still says it doesn't have power, so then we got to do power. Now the residential has power.
And now the residential is being built. And we're playing fucking SimCity, man. Make a little commercial district. And then we got to give them power lines too. Like that. Build a police department. Build a fire department. Look at that. Where's our industrial? Is there there's industrial, right? Yeah, there it is. Make a bunch of that, and then we'll make a road over here. And make more residential. Oh, that's water. That's why I can't do that. And then... like that. Look at that. Oh, you can build, what is this, a football stadium? Oh yeah, gotta have the football stadium. Okay, this was fun. All right, and this fully works, which is so cool. I'm gonna burn a shit ton of floppies for fun. I think people sell the Workbench 1.3 floppies on eBay, and if I can just make a bunch of those, then... I mean, this guy makes a test kit that has... yeah, this guy sells Amiga Kickstart 1.3. It says for the Amiga 1000. Yeah, Amiga 1.3 Workbench for the Amiga 500, 1000, and 2000. The Amiga Test Kit and Extras 1.3. I might do that and just see if I sell some. Because if I sell some, then fuck, it takes me like, what, 10 minutes to make it? So, anyways, you guys have a great night. I gotta get to bed. So, thanks for hanging out. We played some Amiga. Tomorrow we'll probably finish this up by putting the computer all the way back together, and then wrapping this project up by getting the display out cable and, yeah, patching it all up. So, thank you all for watching. And until next time, good night, Yank. Good night, Crazy. Good night, everybody else. Attic, if you're still here, probably not. But anyways, thank you. Good night.